Yes, elastic shocks are key to a successful game of billiards, but how? To find out, stay with us until the end. In our case, the white ball is launched by the player with an initial speed of 3 meters per second, hits the stationary target ball. What do you think will happen? The magic of physics means the white ball stops and the other one starts rolling. Wow! How is it happening? The answer is revealed in the rest of the video. So, the balls in question have the same mass of 170 grams. Of course, to simplify the calculations, some assumptions have been made. See the bottom of the screen. In this section, energy is indeed conserved after the collision. Based on this assumption, we can calculate the speeds of the two balls, which, as you can see, have been swapped. The white ball stops, while the other one starts moving at a speed of 3 meters per second. The formulas governing this are derived from two laws. The first is the conservation of momentum, which gives equation 1, and the second is the conservation of kinetic energy, which gives equation 2. We now have a system of two equations with two unknowns VA2 and VB2, which ultimately reduces to a single equation with two unknowns equal to 0. So mathematically speaking, there are two possible solutions. One of the two speeds is 0, and thus since A stops, B starts rolling with the speed that was transferred to it from A. Dear audience, if you liked the content, don't hesitate to subscribe to our Applied Mechanics channel. Part B assumes that the two famous balls stick together after the collision and travel a certain distance together. You see, when we apply the law of conservation of motion, we obtain a final speed half the initial speed, which will be 1.5 meters per second. In my opinion, this part, C, is very interesting, since it suggests the determination of the dissipated energy. Since the shock is inelastic, part of the energy is lost in deformation, even negligible heat or sound, noise. Here it is 0.3825 joules. If you are a billiards player, you certainly know that you should attack the balls obliquely relative to one of the edges of the table, and when the collision is always assumed to be elastic. The angle between the linear paths of the two balls after the collision is 90 degrees, so if one of the balls tilts at 30 degrees, the other starts at 60 degrees. Finally, the final velocities of the two balls are simply the projections, at the chosen angle, of their initial velocities. Thus, by simple trigonometric calculation, we obtain velocities of 2.60 meters per second and 1.5 meters per second for balls A and B, respectively. Well, in reality, the angles and actual velocities are significantly different since the balls are solids and not point masses. Therefore, rotation and friction cannot be neglected. We hope you enjoyed the billiards exercise. We look forward to your thoughts and suggestions, which are welcome in the comments. And see you soon in another video.